Good morning, students. Welcome back. Welcome back to science class on the chapter light. Just recall what we had studied in the previous class. In the previous class, first we studied different ray diagrams of concave and convex mirrors. Okay. First one, when the incident ray is parallel to principal axis after reflection, it passes through principal focus. Okay, first when the ray is parallel to principal axis, after reflection, it passes through principal focus. Okay, and we know that always in spherical mirrors, always we should draw normal from the center of curvature. This is in concave mirror. Then in convex mirror, this is convex mirror. Convex mirror, now consider ray of light is parallel to principal axis. After reflection, it passes through principal focus. Now see here, now the reflecting surface is outwards. Okay, it is not face, it is away from the center of curvature. So after reflection, it passes like this. Okay, see if you extend this line, then it passes through principal focus. Then we studied ray of light passing through principal focus. See, ray of light is passes through the principal focus. After reflection, say it is parallel to principal axis. Okay. Next, here, ray of light passes through principal focus. Here also, after reflection, that ray is parallel to principal axis. Okay. Next, see, we studied that the ray of light passes through the center of curvature. So it retraces the same path. Okay. If you pass a ray of light through center of curvature, this incident ray, and now see here, if you pass a ray of light through center of curvature, means here you are passing a ray of light perpendicular to the reflecting surface. So that's why here incident ray, normal and reflected ray all are lying in the same path or same line. Okay. Next, we pass the ray of light to pole of the mirror. Okay. So now this is here we are passing a ray of light to pole of the mirror. Okay, so today we shall study the image formation by concave mirror. You know, when you keep the objects in front of the plane mirror, at the time size of the image is equal to the size of the object. If you changes the position of the object, means if you increase or reduce the distance between distance between object and plane mirror, at that time also there is no change in the size of the image. At that time, size of the image is equal to the size of the object. But when you keep the objects in front of a concave mirror, if you change the position of the object, then there is a change in the size of the image. Sometimes at some points maybe it is a smaller, at some points it is a greater, or at some point maybe both are equal, object and image. Okay, we'll study one by one. Okay. While studying image formation by concave mirror, here we use only two rays. Okay, because where the two rays meet at that point, the remaining all the rays are meet at that point only. Okay, so now first consider here, this is a concave mirror. Concave mirror. Okay, so better make one table to understand it clearly. So first one, position of object. Okay, position of the object. Second one, size of the position of the image. Position of the image. Third one, size of the image. Next, Next one, nature of the image. Nature of the image. See, one more thing. Here this is the center of curvature and this is principal focus. Here suppose if the distance between C to F is just 5 centimeter, then the distance between F to B is also 5 centimeter. Okay. See, first I will keep the object at infinite distance. Okay. First I will keep the object at infinite distance. Okay. Here, just consider two rays. Okay. Now those two rays are parallel to principal axis. The rays are coming from infinite distance. Infinite distance. Okay. See, yesterday we studied, right, when the the principal axis, after reflection the rays are passes through principal focus. Okay, so now these two are incident rays. After reflection both are passes through principal focus or meet at principal focus. See here, if you keep the screen here, then you will get the image of this object. Okay, see, I will show you practically. See here, I made some arrangements. See, this is a concave mirror and this is the principal focus and this is center of curvature. See, now focal length of this concave mirror is 20 centimeter and center of curvature. Then the center of curvature here and the distance is that is at 40 centimeter. Okay, so now I have kept the object at infinite distance. Okay, so now when you keep the object at infinite distance, where you will get the image? We will get the image at the F. Okay, see now this is a principal focus. See here, at this point I am getting the image. Okay, I think it is a little bit difficult to see this one. Why? Because it is highly diminished. It means very small. See, at this point I am getting the image. Okay, see now I have kept that object at infinite at infinite distance. I am getting image of that object at F here. Okay, so here position of the object is at infinite distance. Then position of the image at F, and F, that is principal focus. Then what about size of the image? It is very small, because here we won't use that word very small. Instead of that small we use diminished. It is very small, right? So that's why we can write size of the image as highly diminished. Highly diminished or point size. It is very small. Why? Because here we have kept that object at infinite distance. Okay, when you keep the object at infinite distance, we will get the image at the principal focus. Next, what about nature of the image? Nature means whether the image is virtual or real. Okay, if you see virtual images are cannot be caught on a screen, whereas the real images can be caught on the screen. So here we got that image, right? So that's why now the nature of the image is real and it is inverted. Okay, nature of the image is real and inverted. Okay, see, position of the object at infinite distance, position of the image at f. If you keep the screen here, you will get the image. Next, size of the image is highly diminished or point size. Then nature of the image is real and inverted. Okay, yes. So now this is when the position of the object is at infinite distance. Here, see, here to draw, just use your skybar. Then you to measure the angle, just use your protector. Yesterday we have studied, right? Next, move to. I'll keep the object behind the center of curvature. Yes. So now keep the object behind the center of curvature. Okay. See, now position of the object behind C. Behind C. Next, here also consider two rays. I will consider one ray is parallel to principal axis. You know, right? After reflection, it passes through principal focus. Next, I will consider one more ray. That ray which passes through principal focus. You know, when the rays passes through principal focus after reflection, it is parallel to principal axis. See, here both the reflected rays are meeting at this point. Correct? So that's why if you keep a screen here, then we get the image here. Okay? So now position of the object behind C, then position of the image between C and F. Then what about size of the image? Just compare the size of the object and size of the image. This is a little bit small, right? This is a little bit small, right? So we call this is diminution. Diminution. And what is the nature of the image? Okay, we'll check here whether the image is real or virtual. See here, I'm getting image here. See, now this is F and this is C here. Okay, so now I'm getting here the image of the object. Okay, so now, so this is, we are getting that image on the screen, right? So that's why the nature of the image is real here and it is inverted. Okay, so now position of the object is behind C, position of the image is between C and F, then size of the image is diminished, then nature of the image is real and inverted. Okay, yes. So next I will keep the object at C, that is center of curvature. pole of the mirror, principal focus, and this is center of curvature. So now, I'm keeping the object at C. Okay. So now here also consider two rays. One ray is parallel to principal axis, and we consider one more ray, that is it passes to P. Okay. So now this ray is parallel to principal axis, right? After reflection, it passes through principal focus. Okay. So now one more ray which passes to pole of the mirror after reflection. See here, both the rays are meeting here. Okay, so both the rays are meeting here. So now position of the image at C. Then position of the object at C. Then position of the image at C only. At C only. Then what about size of the image? See, just observe here. Both are same, right? So that's why size of the image is same size. Same. Next, what about nature of the image? Okay, let's check. So now I will keep this object at C. Okay, this is center of curvature. Here I think see, now position of the object is at C and the position of the image at C only. Okay, and see, just observe here, I think it is little bit difficult for you. See, now the image is inverted. Okay, see, now nature of the image is realigned, inverted. Okay, see, position of the object at C, position of the image at C only. Okay, then whatever size is same, image size equal to object size. Then our nature of the image is realigned inverted. Okay, see here, you can see, no need to take this way. If you can consider ray of light passes through F, or you can consider here or here. Okay, but after reflection all the rays are meet at this point only. Okay, yes. So next I will keep the object between C and F. I will keep the object between C and F. Between C and F. Yeah, C. See here once again. Here you have to take the same distance from C to F and F to P. Why? Because principal focus, it's the midpoint of C, between C and F. Okay. So now I will keep the object between C and F, that is center of curvature and principal focus. So once again consider ray of light is parallel to principal axis. After reflection, it passes through the reflection, it passes through principal focus. So now consider one more ray. That ray is passes to pole of the mirror. See here. Now these two incident rays are after reflection, both the rays are meeting at this point. Okay, that is behind the center of curvature. Okay, so now position of the image between C and F. Position of the image behind C. Next, what about size? Just observe here. This is the object side. This is the image. I think it is greater, right? So here instead of greater or bigger, we use enlarged. Okay, right. So position of the object between C and F, position of the image behind C, then size of the image is enlarged. Okay, now let's check the nature of the image. So now I will keep the object. Now I will keep the object between C and F. See, at this point I am getting the image. Okay. See, now the position of the image is behind C. Okay. Now what about nature? Nature is, it is real because we are getting on the screen, right? So that's why nature of the image is real and it is inverted. Okay. So nature of the image is real and inverted. Okay, see, first the position of the object is between C and F. Position of the image behind C. Then size of the image is enlarged. Then nature of the image is real and inverted. Okay. So now I will keep the object at F. Okay, consider one ray is parallel to principal axis. So after reflection, it passes through principal focus. Next, consider one more ray passes to P. See, just observe here. Now these two reflected rays are parallel to each other, which means these two rays, they never meet at one point. So now extend this side, that is behind the mirror. So this side also, so we call virtual rays. These two virtual reflected rays are not meeting. Why? Because both the rays are parallel to each other. Now, where is the position of the object? At F. Where is the position of the image? Okay, here position of the image at infinity. Then size of the image, it is highly enlarged. Next, nature of the image. So here nature of the image is also real and inverted. Okay, so let's check. So I will keep the object at F. So here I am getting the, okay, so here, so now I am getting that image at an infinite distance. So just observe here, it is highly enlarged and it is inverted. Okay, so nature of the image is real and inverted. Okay. See, the position of the image is at the principal focus. Position of the image is, sorry, position of the object at the principal focus, and position of the image at the infinite distance, and the size of the image is highly enlarged, and nature of the image is real and inverted. Here the rays they never meet, but all the rays are very close to each other. So that's why we will get the image at the infinite distance. Okay. So now I will keep the object between F and P. Between F and P. Okay, consider one ray is parallel to principal axis after reflection passes through principal focus. One more. See, observe here. Now these two rays are not parallel. Okay, here when you extend the lines, the distance between the two rays is keep on increasing. Okay, so now just from this side. Here, these two rays are virtually connecting here, so that's why we will get the image here. Okay, position of the object between F and P, then position of the image. So that is behind the pole, behind the mirror. Then size of the image is, it is just observe here. Okay, it is enlarged. What about nature of the image? Okay, let's check. So now okay, so now I will keep the object between principal focus and pole of the mirror. Okay, see, I am keeping the screen here. See, I am not getting any image. If I keep it center of curvature or between C and F, or at F, or between F and P, or I will keep the screen at infinite distance. Okay, so here I am not getting any image. Okay. Now, what is the nature of the image? Okay, so now in this case, nature of the image is virtual and erect. Virtual and erect. So in this case, the images are, when you keep the object between F and C. Okay, when you keep the object between F and C, then the images are formed by a concave mirror are virtual and erect. Except F and P. In the remaining cases, we'll get the real and inverted image. Okay, so now here position of the object is between F and P, then position of the image is behind the mirror, then size of the image is enlarged, then nature of the image is virtual and erect. Okay. Next one table. So now first one, position of the object, then position of the image, then size of the image, then nature of the image. Okay. See, first we kept the object at C. Then where is the position of the image? Then where is the position of the image? At F. Okay. Sorry. Initially we kept the object at infinite distance, right? Infinite distance. Where is the position of the image? At F. At F. What about size of the image? Size of the image is point sized or highly diminished Okay. What about nature of the image? That is real and inverted. Real and inverted. Okay. Then second one. Where is the position of the object? So we kept the object at behind C. Behind C. Then where is the position of the image? Position of the image is between C and F. Okay. What about size of the image? Size of the image is diminished. Okay. Size of the image is diminished. Next, what is the nature of the image? Nature of the image is real and inverted. Okay. Next, third one, we kept the object at C. Okay. Next, then what are position of the image? At C only. At C. Okay. Then what is the size of the image? Same size. Same size. Okay. Next, what about nature of the image? The nature of the image is real and inverted. Okay. Next, so next we kept the object between C and F. Then where is the position of the image? That is behind C. Behind C. Then what about size of the image? Size of the image is enlarged. Then what about nature of the image? We got that image on the screen, right? So that's why nature of the image is real and inverted. Real and inverted. Okay. So we'll write for here. Right, okay, move the table. So fifth one, position of the object at F. At F. Then where is the position of the image? That is at infinity. At infinity. At infinity. Next, what about size of the image? Size of the image is highly enlarged. Highly enlarged. Then, what about nature of the image? Nature of the image is real and inverted. Inverted. Next, the last one, we kept the object at between principal focus and pole of the mirror. So now what about position of the image? That is behind the mirror. Behind the mirror. Next, what about size of the image? Size of the image is enlarged. Enlarged. Okay. Then what about nature of the image? Nature of the image is virtual and erect. Okay. Virtual and erect. See, just observe here. Except this case, sixth one, between F and P, the remaining all the cases, the nature of the image is real and inverted. But when you keep the object between F and P, at that time you will get the nature of the image is virtual and erect. Okay. See, the images are formed by a concave mirror, maybe sometimes virtual and sometimes real. Okay, that depends where you will keep the object. When you keep the object between F and P, so at that time you will get the virtual image and it is erect. Okay. Yes. Yes, I will stop here. We'll continue class tomorrow.